Dave knows how.
Okay, welcome back to my channel. We're going to kind of go over wiring a motor with a reversing switch, and we're going to try to make this as quick as possible. So what we got right here is a diagram of a motor. I know it doesn't look like a motor. Trust me, it's a motor. Now, what kind of motor is it? It's a 115 volt single phase motor, which starts with a start capacitor and has a run winding. So right over here on the left hand side you'll see W1, little squiggly lines. This is your motor winding, and it is the run winding. It's the winding that actually makes the motor run so that you can use it. It maintains the amperage, the torque, the RPMs, the whole 9 yards pretty much once the motor is started. Now this W3 winding, this is your start winding. And what this winding does, it determines the rotation of the motor. So if you want the motor to rotate counterclockwise, this little thing right here is what does it. If you want it to run clockwise, this is the winding that does it. So we're going to show you very simply how changing the rotation of the motor can be done. It's best if you understand the fundamentals as to how the motor changes rotation so that you can discover what type of switch you have and what the best method is to make it change rotation. Okay, so we've went over the run windings, we've looked at the start windings, and we got to wonder, what is this C1? Okay, and this little configuration right here, a little symbol. This is actually a capacitor, and the capacitor in this scenario is a start capacitor, and what it does, it acts almost as a battery. It stores electricity. Even though this motor runs on 115 volts, the start capacitor will hold a whole lot more than 115 volts, and that large amount of voltage is what shocks this winding, this start winding, into being able to make the motor actually turn over. Okay, now this S1 symbol is a switch. Now it's not the switch that turns the motor and turns on and turns the motor off. It's actually a centrifugal switch that's built inside of the motor. And when the motor's not running, the switch is in the closed position, which means that rather than the handle being in this position going up like this, the handle is actually closed. So electricity runs from this hot wire in here, up here, through the switch, charges the start capacitor, goes through the winding in this direction, causing the motor to rotate in that direction, and then goes out this side, and the unbalanced load goes back into the neutral. Once the motor starts and gets up to speed, this centrifugal switch will release and open this switch up. So now electricity cannot flow across here, and electricity stops flowing across here, but it continues to flow down this yellow wire into the run winding. And because the start winding has initiated a rotation, this run winding will continue that rotation in the direction that the start winding initiated. And it will continue to run the motor until the power is removed from the motor right here by either unplugging it or adding an additional switch somewhere out here. Now let's take a look at how we can change the rotation of this motor. Very simplified. What we would do is we would remove this wire. We would also remove this wire. Oops. Then we would take this wire and we would run it over to there. We would then take this wire and we would connect it here. What this does is, what this does is the electricity is going to run through here initially. And instead of coming in through this end and rotating this way, causing the motor to turn this way, it's going to come in this way and make the motor turn the opposite way. Come all the way out the end and take the unbalanced load back to the neutral. So this is a very simplified way to explain how a motor rotation changes with the use of a start winding, a start capacitor, and some type of switch. In this case, a centrifugally operated switch internally made in the motor. Okay, let's back up to here again. Let's take note of this label right here that says T5. We'll also take note of this label here marked T8. We want to remember those two terminals. Those are actually the wire labels that are inside of the motor that I put on my lathe, which came from Harbor Freight. Now before we get into those two wires and get into the switch, let's talk about this centrifugal switch. It's good to know how this centrifugal switch actually operates. So I've downloaded a picture of a centrifugal switch that they typically put in a motor. This is what it looks like. This is the centrifugal part of the switch. It has springs right here and these counterweights, one on this end, one down here on this end. The motor shaft goes through this hole. This whole device spins into a rotation. When it gets up to speed, it actually slings these weights out this way, slinging this weight down this way. Typically, when it's not rotating, these weights are sprung in and they apply pressure right here and right here. When it applies that pressure onto this plate, which is part of the switch, it actually makes the switch make contact. The switch has a spring in it. When this thing spins around and these weights sling outward, this switch drops out, and that's what breaks the power. This switch is actually this switch right here. I hope it makes you understand better how this switch operates. This is not a switch that's on the outside of the motor that you can turn on and turn off. This is a switch that's mechanically controlled by the motor rotation itself. Let's take a look over at the next diagram. Okay, in this next diagram, one of the things that we want to note right off the bat is two items. One is this T8 and this T5. You remember in the previous diagram, I pointed out T8 and T5, and I told you to keep those in the back of your mind. Well, that's why. That is T8 and T5. Those are those two wires that are connected to that start winding. Now, if we look up here at this diagram, it's divided into two categories. This category on the left-hand side is counterclockwise rotation. On the right-hand side is clockwise rotation. Let's start with P1. We'll notice that the wire that comes out of the motor that is labeled P1 is connected to the wire that is labeled L1. You might ask, what is the wire L1? There's not one in the motor. Well, wire L1 is the line wire, which is the wire that is actually plugged into the receptacle to power the motor. L1 is typically the neutral out of that 120 volts. It's generally the white wire. No matter if you're running in counterclockwise or clockwise rotation, L1 is always connected to P1. You can see that clearly in the diagram. Under counterclockwise and clockwise rotation, L1 is connected to P1. If you look down the counterclockwise rotation column, you'll notice that P2, T3, and T8 are all connected together. The wires that are labeled P2, T3, and T8 come out of the same side of the cover as P1 on the side of the motor. When you pull that motor cover off, you will find P1, P2, T3, T8, T2, T4, and T5. In order to make the motor rotate in counterclockwise rotation, you need to tie P2, T3, and T8 together. You then need to tie T2, T4, T5 together along with L2. You might ask, what is L2? There's no L2 coming out of the motor. L2 is the hot wire coming out of the cord that you're plugging into the wall, or if you've added a switch, it's coming out of the switch as the hot wire. Now on clockwise rotation, we'll note again that P1 is connected to L1, which is the neutral. You'll also note that P2 and T3 are connected together. You'll also take note that now P2 and T3 are no longer connected to T8 as they was in counterclockwise rotation. They are now connected to T5 for a clockwise rotation. You'll also notice down further that T2, T4 are connected together, but they are not connected to T5 as they were in counterclockwise rotation. They are now connected to T8, and they are also connected to L2, which is line 2 or the hot wire. So if we take note to what has changed, P2, T3 are connected together. P2 and T3 are also connected together in clockwise or counterclockwise rotation. That's something that is constant and does not change. We need to take note to that. We also need to take note that down here, T2 and T4 are connected together with L2. Additionally, we need to note that T2 and T4 are also connected together with L2, even in counterclockwise and clockwise rotation. What has changed? What has changed is T8 and T5, which brings us back to our first diagram. That's exactly what we need to change, T8 and T5. So let's see how they change it over here. The way they change T8 and T5 is they change T8 and T5 from connecting to P2 and T3 or T2 and T4. Notice we've actually got a crisscross pattern. T8 goes down here, T5 goes over here. So that's basically how we're changing the rotation of the motor. Now, how does that apply to our drum switch? Well, first let me tell you there's a lot of different drum switches. And this is only one variation of a drum switch. So it's very important that you understand how the motor works and how to get reverse rotation so that you can apply it to the drum switch that you actually have. This drum switch that I'm going to show you is a typical drum switch that everyone shows online. It's the standard drum switch that is basically for single phase use, 120 volt or 230 volt. This particular drum switch cannot be used for three-phase. This is not the drum switch that came on a lot of Craftsman Atlas lathes. My Craftsman Atlas lathe actually came with a drum switch that can be hooked up single phase, three-phase, DC, induction, many different configurations. You need to look inside the cover at the diagram and decide which diagram best suits your needs. We're going to go over this diagram real quick. Over in the diagram on the left-hand side, in counterclockwise and clockwise rotation, the first thing that we noted was that the wires P2 and T3 stayed the same, no matter if it was counterclockwise rotation or clockwise rotation. They continuously tied together. Also, we noted that T2 down in the orange and T4 stayed the same. They stayed tied together no matter if it was clockwise rotation or counterclockwise rotation. So let's look over at the connection diagram and let's see what stays the same whether we're in forward or reverse. So if we draw a line down through the middle of this diagram, we'll notice on the left side of the knot, on the left side of that black line, we have the configuration for forward movement. If the switch is in the forward position, this is how the connections go. Terminals number 1 and number 2 are connected together, along with terminal number 3. Terminal number 4, 5, and 6 are connected together when it's in the forward position. When we look to the right of the line, we'll notice that when the switch is in the reverse position, terminals 1, 2 are still connected together, just like they are in the forward position. But terminals 1 and 2 are no longer connected to terminal 3 as in the forward condition. Terminals 1 and 2 are now connected to terminal number 4. Also, we'll note that terminals 5 and 6 are now connected to terminal number 3, whereas in forward position, terminals 5 and 6 was connected to terminal number 4. So we can see some constants and we can see some variables. The constants in this scenario is When we're in forward or reverse, terminals 1 and 2 in both configurations stay connected. Also, we can note that whether we're in forward or reverse, terminals 5 and 6 are in constant contact. No matter which way we have the switch, forward or reverse, they're still connected. That's very similar to our schematic on the left-hand side, where we see that whether we're in counterclockwise or clockwise rotation, or forward or reverse rotation, our constants are T2 and T4 are connected. Also, our constants are P2 and T3 are connected. This would mean that P2 and T3 should possibly be tied to terminals 1 and 2. The wires labeled T2 and T4 would make sense to be connected to terminals 5 and 6. What changed over here in this switch was terminals 3 and terminals 4. When we switched from forward, when we were in forward position or counterclockwise position, terminal 3 was connected to terminals 1 and 2, and terminal 4 was connected to 5 and 6. But when we switched to reverse position or clockwise position, terminal 3 is now connected to 5 and 6, and terminal 4 is now connected to 1 and 2. This is exactly what we need. This is exactly what we need to happen. We need wire number T8 to no longer be tied to T3 and P2. And we can do that by attaching T8 to terminal 3. We can connect T5 to terminal 4. This will allow for when we're in forward position, T8 will be connected to terminals 1 and 2. And T5 will be connected to 5 and 6. When we switch over to reverse conditions, we will no longer have that scenario. T8 will now be connected to 5 and 6. And T5 will now be connected to 1 and 2. I hope this makes some sense to you and will help you to be able to figure out how to wire whatever switch you have. It still may be somewhat of a mystery because you may not have a switch that operates exactly like this switch does, because as I said before, there are many configurations of drum switches out there. You really have to look at the drum switch that you have and figure out which one it is and which wiring diagram you need to use. Most of the drum switches have a wiring diagram in the lid. If you take the cover off and look underneath it, you'll see a wiring diagram. You can also look up the wiring diagram for drum switches by getting the model number of that drum switch and looking it up online. If all that fails, you can use an ohm meter to put the drum switch in various different configurations and ohm out each terminal and figure out what happens when and why and how. Take notes and write that down. Then revert back to this information here. Mainly revert back to the first part of this video where we go over how the motor works and what you actually need to change in order to reverse a rotation between T5 and T8. Now, with all this in mind, you need to keep one important fact. The motor must come to a complete stop before you reverse the direction. If you try to simply reverse the direction while the motor's still turning, it'll just keep turning in the direction it's going in. You have to let the motor come to a complete stop. I hope this sheds some light on the mysteries of getting a motor to reverse in somewhat of a simplified manner that is not so generic that it's not going to work for you. I think understanding how these motors operate, and the motor that I'm actually going over is a single phase motor with a start winding that utilizes a start capacitor to start it in the direction it needs to go, which is typical of the 1 horsepower Harbor Freight agricultural duty electric motor. I believe that motor comes in 115 or 230 volt scenario, and this switch diagram should work for either or. Thanks for watching my video.
Don't forget to rate, comment, and subscribe. Thanks for watching.